A very warm greetings to all of you, dear authors and invited guests. Welcome to the technical session 3C. Myself Gargi Kalra, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you all to the 8th International Conference on Information and Communication Technology for Competitive Strategies, ICTCS 2023, Jaipur, India. The 8th edition of the conference is being organized in a hybrid mode. The physical event is organized today in Jaipur, India, and the virtual event is being held through Zoom today and tomorrow, that is 8th to 9th of December 2023. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentation and 2 minutes for the questions and answers. On 7 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks because we need to take a snapshot for this conference at the end. If you have any query or update, then you can write it to me in the chat box. Just before we get started, I would like to introduce you all to the chair for this session, Dr. Parikshit Narendra Mahalle. He is a professor and head at Vishwakarma Institute of Information Technology, Pune, India. He has more than 19 years of teaching and research experience. He is reviewer for Springer Journal of Wireless Personal Communication also. Reviewer for Journal of Engineering Science and Technology, School of Engineering, and Taylor's University. Sir, would you like to share a few words with the audience?
At the outset, a very good afternoon to one and all. And thank you ICTCS for giving this opportunity to all the presenters as well as me to chair the session. I would like to congratulate all presenters and as already mentioned by Gargi, please stick to the time for your presentation and let us know your key contributions in your publication. So all the best to all presenters. Thank you, Gargi madam. Over to you.
Thank you, sir. So let's move with the paper presentations. So the first paper we have is a case study in requirements analysis, Sakhi, Software Portfolio Manager, and this will be presented by R.V. Krishna. You can share your screen and start the presentation.
I think so. He's absent right now.
Okay, so let's move to the next paper. The next paper is a secure health monitoring model for prediction of heart disease detection using machine learning. And this will be presented by Bhargav P. Padya. You can share your screen and start the presentation.
Is anyone here from this paper? Gargi, you should move forward because he is not.
Let's move to the next. So the next paper is AI-enabled heart sound analysis, Pascal approach for precision-driven cardiopulmonary assessment. And this will be presented by Gaurav Kumar.
Yes, ma'am.
Yes, you can share your screen and start the presentation.
It is visible now, ma'am?
Yes, it's visible.
Okay. Very good afternoon, all dignitaries present over here. Myself, Gaurav Kumar, researcher scholar in the Department of CA, GLA University, Mathura. And today I am presenting paper title is AI enable heart sound analysis Pascal approach for precision driven cardiopulmonary of the assessment. And these are the indexing part, abstract, introduction, existing work, methodology, result, conclusion, references. First of all, we have to abstract part, and an automated system for analysis heart sound was developed named just like the Pascal, and we have to high precision was achieved with a score in of 94.38%, and upon test is accuracy the 93.52 when categorized just like the heart sound, and uh, perform an just like the analysis of importance element of heart sound such as the duration of S1 S2 and just like the cardiac cycle and the diagnostic phases, and the we have to improve the accuracy of clinical evaluation by the component of the different causes by the location and segment pair, and the introduction part we have to see the make the switch for manually analysis heart sound where medical professional for using automated approaches that were one of the more accurate method. And this paper we have to see the introduce Pascal and cutting of the edge method with the combining automated and accuracy, and it stretches with the uh, machine learning and component of the clinical images, and we have to demonstrate the strong performance metrics focusing on the ECG data and key heart sounds like the S1 and S2 duration and the cardiac cycle. And Pascal effectively regardless of the variability in the heart sound due to the factors like the sigmographic meter and the placement and the background we have to see in the part of the in the highlight the challenges of the natural heart sound drivers of the ECG data analysis due to psychological variations such as the electrode placement and blood circulation dynamics, and discuss the various method to heart sound analysis including the ECG statistical modeling and time frequency domain techniques such as the unique benefit and the challenges, and notes the popularity of the evaluate based on the method of preserving circular data while the maintaining simplicity of the use of the segment heart sound wave, and suggest of the approach combine the according of the method just like the maximal uh, change junction just like the ECG data interpretation, and the we have to related word the some paper highlights the work of the ECG data, the psychological difference such as the location, electrodes, and dynamic blood circulation, and the gathering the variety of the genius of the heart sound. And some paper we have to discuss more some approach to heart sound to such as the electrogram and statistical modeling just and techniques to operate the time frequency domain and each of the advantage and disadvantage we have to see, and research gap we have to article of the blood identify the real-time analysis and forecasting of the heart sound, especially the noisy environment of the or with patent of the respiratory of the conditions, and current tool focus on the mainly post capture analysis lacking the real-time processing capability and limited research in the heart sound analysis techniques into variable device or continuous monitoring, and uh, we have urgent need to continuous real-time cardiovascular monitoring to enable the prompt of the treatment and improve the patent outcomes. And the research objective we have to say implementing the Melior method of the improving approach just like ECG signal analysis potential and unproving of the unique insight, and the Pascal data sets standard cardiac sound and benchmark of the compare in the new method against the established, and expanding the validity by the using various database, ensuring that the method applicability and effectiveness across the different scenario and data set. And the proposed methodology we have to introduce a computer asset in the uh, device and non-insensitive and can detect heartbeat, and this technology provide the of the elementary just like the traditional of the procedure, and utilize the advanced technology to record collect and amplify of the heart sound, which then the analysis using the complex statistical techniques and signal processing, and limit of the need to doctor manually to uh, be fond of the signal, providing the solution that not only the portable but can also cost effective and easy to use, and attention the direction of the control and simplify of data with between when normal and abnormal heart sound based on the specific cardiac cycle component. And these are the proposed methodology. First one, the heartbeat sound recorder. This process began to be device which is the responsible to the just like the capturing heart sound from the patent. And next one, the after heartbeat sound record, then the collect sample data, and sample data the record the heart sound, and the collected are sample data for analysis. And after that, the pre-processing and pre-processing the two mainly step, evaluating signal quality and filtering. Evaluating signal quality, the quality of the heart sound, just like the sound signal in the access of the ensure that just like the addict of the analysis. And filtering, the signal is filtered to remove any noise or irrelevant information that could interface with the analysis. And after that, the segmentation during segmentation phase, the filter heart sound the divided into segment, and identify the heartbeat, and each segment analysis to identify the individual heartbeats within the signal. And after that, the classification to classify the sound identified heartbeat are classified based on their characteristics. And this could involve just like the determine whether the sound correspond to normal heart function, or if there are many abnormalities such as the murmurs. And the clinical application. Finally, we have to see the result of the classification are used in the clinical settings, and to diagnose and treatment planning and monitoring of the heart condition. And these are the system to process of the data collection and clinical decision making, the automatic the analysis of the heart sound. And next we have to an automated framework for ECG signal analysis using the Miller approach, and the focusing of the on the significant and sudden the changes in the ECG, and utilize the Pascal data set, understand the benchmark, but based on the challenging the classify and recognize heart rhythm illness of the condition. And comparative of the competitiveness with the other database offer a new insight setting in the stage for application enhance the techniques details. And these are the work system to automated ECG signal analysis to framework developed by the Miller technique, and focusing of the detection of the sudden change in the ECG signal and Pascal data set to heart sound, and serve of the benchmark at the method faced on the different difficulties in the classifying heart rhythm under disease condition. And the conceptual method show the effectiveness of the decomposing of the pulse signal adaptively of the head handling variability due to different signal locations. And these are the flow diagram. The this diagram to a step involved with of the sound level survey at just like the particular site. And the first one is the deciding where to the take sample. And the first step to determine just like the specify the location whether within the site where sound sample will be located. And next the surround region of the desired site. This means sampling point are decided are the surrounding region or to desires considering of the survey assessment of the environment immediately adjust the desired sampling point. And the next survey of the sampling data, sampling area in actual survey, examining just like the sampling area, the conducting and understanding the physical layout and noise measurement. After that, the evaluating of the data, and these are the result and discussion. The Pascal data set was used in the order to evaluate the coding methodology and using the set of a and we have and different between the healthy and abnormal sound, and to demonstrate both of the strength and limit sound. And the method achieved the 72.25 reliability on data set A, and 93.5 with the data set B. And the according of the method demonstrate high accuracy in the classifying of the mission of result across and various conditions, and required of the further pathological sound analysis. And these are the conclusion part. ECG signal analysis highlighted the complexity of the improve the precision and ECG signal brought of the light, and improve the classify of the sound or heartbeat. And excellent knowledge just like the signal dynamic was on the fact that the computational efficiency of 91%, and was the achieved data set via reliability of rate, and the 70.97% was achieved of the data set A. And there were the difficulty of the cardiac sound, because the interactive and variety of the sound which resulted performance disparate of the across data set base. And the future scope behind it comes to improve the detection and classification of complicated cardiac disorder, to the further sound of the focus on the developing more advanced AI and ML algorithm. And when it comes to ensure that the cutting edge of approach of the application clinical settings, just like the collaboration with cardiologists are very necessary. And by incorporating of the real-time data analytics into the cardiac testing, and it will be possible to improve the diagnosis and develop a procedure that more relevant and across the wider range of the situation. And these are the references. Thank you.
So what was source of data set? Where you have taken this data set?
Pascal dataset.
Pascal data set. And was it time series data or it was not time series data?
Sorry, sir.
Was it a time series data set?
Time
series. Do you know what do you mean by time series data?
Time series data means just like the visual and time series.
Okay. Have you performed any data engineering?
Data engineering, no, sir.
Okay, fine. Thank you.
Thank you for your presentation. Let's move to the next one.
Gargi, there's one announcement for the participants before moving ahead. I request you all to please stay connected with us till the closing remarks so we can capture the good memories of this virtual conference. Okay, Gargi, move ahead, please.
Okay. Thank you. So let's move to the next paper. And it is an international intelligent traffic control system incorporating deep learning and computer vision with prioritized and dynamic timing. And this will be presented by Ashwin Sasi. You can share your screen and start the presentation.
Hello, am I audible?
Yes, you are audible.
Okay, I'll share my screen. Okay, may I start?
Yes, you can start.
Good afternoon to one and all. Good afternoon to one and all present here in the conference. My name is Ashwin Shashi, and I'm here to talk about our project, Intelligent Traffic Control System using deep learning and computer vision. In our daily lives, traffic congestion is one of the many problems we face. To overcome this hurdle, we have come up with a solution. We have created an analogy and worked further on it. The analogy being, let us take the situation of the policeman controlling the traffic, which is a sight we have all witnessed. According to the traffic present in the junction, the policeman controls the vehicles present in the road. This is considered to be very effective, but it isn't very practical, as the policeman cannot stand in the junction for a very long time due to adverse weather conditions. And so to implement the system, we have taken inspiration from the brain of the policeman to take intelligent decisions, and eyes of the policeman that inspects the traffic conditions of the road. The deep learning model can replace the brain of the computer vision. The deep learning model can replace the brain, and the computer vision can replace the eyes of the policeman. The purpose of a project is to reduce congestion. The purpose of a project is to reduce congestion, improve travel times, enhance road capacity with utilization, minimize fuel consumption, and decrease pollution in urban areas. Using our project, we can analyze real-time data and adjust signal timings accordingly, thus helping in creating an effective traffic flow. The model that we use here is the YOLO model, a state-of-the-art real-time object detection. Now, the problem we aim to address is the significant traffic congestion in urban areas, which lead to delays, decreased productivity, increased fuel consumption, and heightened pollution levels. Traditional traffic control systems are unable to adapt to changing traffic conditions. Here in the slide, we have a list or statistics that we have obtained of traffic congestions in India. The first one being the TomTom Traffic Index 2020 is the source. Ranked several Indian cities among the most congested in the world, including Mumbai, Bengaluru, and Delhi. Another study by the Boston Consulting Group estimated that traffic congestion cost the economy of Mumbai around 1.5 lakh crore, which is roughly $21 billion annually. According to the Center for Science and Environment, traffic congestion in Indian cities results in an estimated fuel loss of over 1.47 lakh crore rupees, which is roughly $20 billion per year. In total, we have addressed 6 SDGs, and in total, 6 SDGs are applicable in our project, them being SDG 3, good health and well-being, SDG 9, industry, innovation, and infrastructure, SDG 11, sustainable cities and communities, SDG 13, climate action, SDG 16, peace, justice, and strong institutions, SDG 7, affordable and clean energy. But we focused on SDGs 9 and 11. SDG 9, industry, innovation, infrastructure. The system requires technological innovation, infrastructure development, contributing to efficient and sustainable transportation systems. And SDG 11, sustainable cities and communities. Intelligent traffic control systems create sustainable and livable cities by reducing congestion, improving air quality, and enhancing transportation efficiency and accessibility. Here we have done literature reviews, and we have referred to the following papers for our research. A computer vision based approach for automated traffic management as a smart city solution, 2020 paper. Smart traffic management system using deep learning for smart city application, 2019 paper. And intelligent transportation system, 2010 paper. Now moving on to the methodology of a project. We are utilizing the YOLO model algorithm, a deep learning algorithm, for accurate and real-time detection of vehicles from the camera. The model analyzes each frame and detects the vehicles on their bounding boxes and classify them accordingly. We detect emergency vehicles and differentiate them from normal vehicles and give priority to them. The valuable information from the detected vehicles are extracted using the YOLO model, and it is given as input to our Python code. This information is used to analyze the traffic patterns and give great insights into the current traffic conditions. The vehicle count and traffic data is also utilized to dynamically adjust the timing and coordination of traffic signals. The system continuously monitors traffic conditions and allocate timings based on detecting emergency vehicles, if there are any, and vehicle count and traffic density in real time.
I think your PPT is freezed. Can you reshare the screen?
Okay, sure. Is it okay now?
Yes, yes.
Okay. Okay. So the obtained information is utilized by the Python code for dynamically determining and changing traffic light signals to green or red based on real-time traffic conditions. Here is a flowchart of our methodology. There are 4 lanes. It captures the video of each lane. It goes through video pre-processing, and then a yellow object detection detects the vehicles. And then it detects if there are emergency vehicles like ambulances or fire trucks. And then it takes count density of each lane, and it goes through Python code logic and gives priorities to emergency vehicles if there are any. Otherwise, it gives priority to the lanes, which differentiating after the.
Yeah, we are not able to hear you.
Ashwin, you are not audible.
I think there is some network issue.
Gargi, wait for more 5 seconds. If he is not coming, then let's moving ahead for the next presentation.
Okay, sure. I think he has not joined, so should we move to the next?
Yes, please.
Okay. So the next paper is Exploring VANETs and Their Applications with Blockchain. And this paper will be presented by Sri Charan ML. You can share your screen and start the presentation.
Good evening, everybody. Can you please confirm if I can hear me?
Yes, we can hear you.
Let me share my screen. Yeah, is my screen visible?
Yes, it's visible.
Good evening, everybody. I'm Sri Charan, and I'd like to present our paper titled Exploring VANETs and Their Applications with Blockchain. These are the topics I'd like to cover as a part of the presentation. Firstly, the introduction and motivation behind the paper. Secondly, some background research we've conducted. Thirdly, I'd like to walk you through some simulations we ran to explore the VANET communication protocols. And lastly, we'll briefly look into an application and conclude. Vehicular ad hoc networks are analogous to mobile ad hoc networks, where every node is a vehicle. This is a network where there is frequent node mobility and dynamic topology changes. To address these characteristics of VANETs, multiple communication protocols have been designed. VANETs generate a vast amount of real-time data, and by leveraging ML techniques, patterns and trends within this data can be analyzed to optimize traffic management. The motivation behind the paper is as follows. There's a high amount of road accidents due to delay in communication and lack of coordination between vehicles. We wanted to explore and understand the communication protocols which would facilitate communication between them. We also wanted to demonstrate the data collection aspects of VANETs and the application that can be done out of it. Moving on to a few important concepts from the background research. Firstly, WAVE. Stands for Wireless Access in Vehicular Environments. It is an extension of Wi-Fi that has been modified to accommodate the characteristics of VANETs. WAVE operates at 5.9 GHz and provides low latency communications. Data transmission in WAVE happens in 2 ways, over UDP or TCP using IPv6 and using the WSMP. WSMP is used to broadcast short and quick messages. It stands for Wireless Short Message Protocol. The messages broadcast using WSMP are also called basic safety messages and include important information such as vehicle position, speed, acceleration, etc. I'd like to introduce you to a scheduling protocol used by Wave devices. Wave devices operate on 2 channels, the control channel which is used for standard broadcast using WSMP, and the service channel. This is used for service-related messages and data transmission using IPv6. Wave devices keep alternating between the control channel and service channel as shown in the image. Now, I'd like to take you through some simulations we ran. We have used NS3 for all our simulations. The first simulation is a scenario where there is simultaneous broadcast and unicasting. In this system, there are M RSUs, which is 2 in this case, and there are N vehicles where one half of the vehicles are moving with a constant velocity V1 and the other half with velocity V2. These are the RSUs and these are the vehicles. This simulation can be visualized as follows. The vehicles are moving with a constant velocity, the RSUs being these two nodes. The mechanism that happens in this simulation is as follows. The RSUs broadcast messages using WSMP from a control channel at a regular interval. Vehicles receive this broadcast and sends the unicast acknowledgement using IPv6 UDP from the service channel. RSUs use this acknowledgement to maintain a dynamic table wherein they always know the vehicles in their vicinity and the vehicles know the closest RSU. This is very useful as RSUs can collect vehicular data and broadcast any emergency signals. Vehicles, if some emergency situation arises, they can broadcast it to the RSU, and the RSU can broadcast it to every other vehicle in the vicinity. The results of the simulation are somewhat like this. You can notice in purple the addition of where the RSUs are adding nodes to the table, and in red where they are removing the nodes from the table. So this way, the RSU always maintains a dynamic table of what all vehicles are close to it. The next simulation is a simulation of a WSMP-based neighbor system. We've used two scenarios in this simulation. The first one is on a custom map, which is a simple highway junction with a traffic stop. The second one, we've used a real-world map around BMS College of Engineering, Bangalore. In this simulation, the algorithm is as follows. Vehicles are constantly broadcasting a WSMP signal at regular intervals. Other vehicles receive this broadcast and then they add them to their table and record the last beacon time they received it. And vehicles also regularly scan their table and remove the nodes where the last beacon time was above a certain threshold. This enables the vehicles to constantly maintain a dynamic list wherein they know the list contains all the other nodes that are close to it. This is a simulation. The first scenario is a simple highway junction. We've used Sumo to generate a custom map and also simulate traffic on it. And this is the NS3 simulation that is run on the simulated traffic. The second scenario is a real-world map. We've taken it out of OpenStreetMaps and we've simulated traffic on the map using Sumo. And on this traffic, we've run our algorithms using NS3. The results of this simulation are as follows. You can notice in red that a node is removing a neighbor from its list, and in green that it's adding a neighbor to its list. So this way,
I think you can go to the concluding part because this is fine. This is, we can see the simulation.
All right. Yeah. So from the data collected using manage, many applications were built. One such application that we've explored is a traffic flow prediction. So we create an Ethereum blockchain where each RSU is a node and then adds the vehicle data, and it takes the vehicle data it collects and adds it to the blockchain. The data in this blockchain is later retrieved to train an ML model that can predict the traffic flow at any time and location. To conclude, VANETs have proven to be effective in enhancing traffic management and safety. VANET communication protocols really facilitate real-time information exchange and improve the safety. In this paper, we've explored the current communication protocols used in VANETs in order to determine how well they enable interaction between nodes in a model network. Any questions?
Yeah, which MAC layer protocol you have used in your simulation?
Can you please repeat that?
Which MAC layer protocol you have used in your VANET simulation for NS3?
A wave protocol. We use
Can you
something
hear
called
me?
Yep, I can hear you. We use something called the wave protocol.
No, I am talking about MAC layer protocol.
MAC layer, it's an extension of Wi-Fi. So the MAC layer is whatever is used with the Wi-Fi itself. Only the data link layer is edited to suit the WAN it needs.
So in your simulation, which protocol is used? My question is very simple.
We use Wi-Fi and then we extend on it with WAN wave.
Wi-Fi is MAC layer protocol?
The one that is used, I mean, we've just taken the standard Wi-Fi protocol and extended using
What is IEEE version of Wi-Fi?
802.11.
So 802.11 is not a MAC layer protocol. My question is with respect to the MAC layer standard which is used in the simulation, right? Because that impacts a lot, right?
Yep.
Okay, and then how many radio channels you use in the simulation?
2 channels. 2 channels.
Okay, fine, good, thank you.
Thank you.
Thank you for your presentation. I think Ashwin's PPT was left in between, so you can continue with your presentation.
I apologize. My Wi-Fi disconnected.
No problem.
So
Can
I
I
think
share?
we can start with the fresh presentation and we can take it later. That would be better.
Okay, sure.
Okay, no problem. So let's move to the next one. And the next paper we have is Green ICT Exploring the Role of IoT-Enabled Technologies in Small-Scale Businesses. And this will be presented by Subhashri Raut. You can share your screen and start the presentation.
Thank you, Gargi. Please allow me to share my screen. Am I audible?
Yes, you're audible.
Good evening to one and all present over here. So I am Subhashri Raut from KTV University, Odisha. Today I am here to present my topic Green ICT, exploring the role of IoT-enabled technologies in small-scale businesses. So, like in the present era, the optimization of energy utilization is of paramount importance for businesses to enhance their operational efficacy, curtail their expenses, foster ecological sustainability, and in order to do so, the present study examines the principal obstacles encountered by small scale businesses in the domain of resource consumption and how green IoT based systems can provide solutions that facilitate real time monitoring and automation that would revolutionize energy management objectives. This study also enlightens the significance of proficient communication and marketing strategies in advancing environmental conscious behaviors in order to enhance customer loyalty. So, with the integration of information and communication technology, like internet connectivity, network infrastructures, wireless communication, telephones, there is always a threat of the rise in greenhouse gas emissions, like which can lead to serious climatic consequences, like rise in temperature, elevated sea levels, frequent floods, storms, which is affecting the equilibrium of the ecosystem. So, therefore, it becomes important to address the issues pertaining to climate change, which requires strategic goals. And these goals can be addressed through green communication and networking systems that focuses on decreasing energy consumption, promotes environmental consciousness, developing environmental tracking, monitoring systems, and safeguard and revitalize the ecosystem. So, green networks aim to provide reliable and efficient connectivity while minimizing the environmental impact through the use of ICT resources, products, tools, technologies, along with the green behaviors like recycling, virtualization, telecommuting, thereby enhancing the optimization of resource consumption, waste reduction, promotion of sustainable practices, and many more. So technologies like artificial intelligence, big data analytics, Internet of Things, information and communication technology, all are advancing to achieve these sustainable goals. So here, two novel approaches like green ICT and green IoT arises. where the latter extends the principle of the former by employing information and communication technology in gathering and exchanging of data through interconnected devices in a manner that is both sustainable and beneficial. With the emergence of Industry 5.0, businesses have a crucial responsibility to encourage the adoption of green IoT solutions in order to have a sustainability focused business model that would enhance resource consumption, minimize expenses, support sustainability, and to attain competitive advantage in marketplace. So, such implementation methods can be used by using green IoT in small scale businesses. Like, in order to implement such things, the role of IoT in these businesses goes beyond operational efficacy and improving customer experiences also. So additionally, it has the potential to enhance eco-friendly practices and to monitor and elevate business environmental footprints. Through several ways, IoT can be advantageous with small-scale businesses like in managing energy consumption, waste production, logistics and supply chain, power, proper usage of water, usage of other sources, and also in reducing carbon footprints. So my first aspect of the implementation of IoT in small-scale business will be energy management. So how it is helpful to us. Like IoT devices can effectively monitor energy consumption patterns in real time and help energy enterprises users to execute energy saving strategies through implementing intelligent thermostats, light controls, power monitors, and to automatically adjust energy consumption according to the occupancy level. So, when if we implement a motion sensor system can be implemented like in a small retail store in order to activate lighting when customers are detected within the vicinity. Similarly, a small bakery also can use IoT energy monitors for the purpose of monitoring oven usage and optimizing baking schedules in order to enhance energy efficiency. So a model is also appropriate model is also given like a smart energy management system. It can also be integrated, which will be helpful to offer real-time data on energy consumption pattern and can be implemented by small-scale businesses to conserve energy, reduce usage, and also environmentally it is better. Then my second significance here I have observed is like in managing waste. So implementation of IoT sensors and intelligent waste bins has the potential to manage waste by monitoring waste level, optimizing waste collection path, minimizing unnecessary pickups. Like here I have proposed a waste bin, my waste bin, that has a container lid which encloses with equipped sensors. It is enclosed with equipped sensors that would measure the level of waste filling which then emits a signal by the load cell indicating to be carried by smart beam tracking module through GPS, which the user can also use through the apps. So in this case, it can be applied for a small scale restaurant business who can like a person can use this IoT enabled beams that can alert waste management teams on approaching maximum capacity, like thereby encouraging proper waste management practices, reducing truck fleet, minimizing fuel usage, and also optimizing pickup schedules. Like additionally, like this installed sensors also have the capacity to detect and determine if the appropriate item is being recycled, it is appropriate or not. If it is a liquid waste or a solid waste, it can also be managed by this waste bin. So next in my list is this supply chain management. So IoT is also, green IoT is also helpful here. Like supply chain management, it includes sourcing of raw materials from vendors, manufacturing goods in a safe and intelligent way in order to be determined that the thing that is received by the customer is the proper quality. So it includes the first one is the smart transportation, how the transportation can be smart. Like if IoT, like here IoT provides transmitting embedded modules in vehicles with GPS devices to determine and send automobile location status that holds the potential for cost reduction, prevention of cargo loss, and also decreased fuel consumption. Again, in the case of warehousing, a short-range communication system along with IoT devices can streamline warehousing operations and enhance management. Like in the case of a furniture retailer, here he can use IoT sensors to monitor and track the precise location of the product within the warehouse, and that will facilitate and enable him to mitigate the risk of stock out products. And then smart distributors, like here smart technologies like radio frequency identification can be used along with IoT programs. Like it will be advantageous in determining like precise location and subsequent delivery of the goods. It can be applied in the case of a food manufacturing industry, like which can use IoT sensors to monitor and regulate temperature of the
Bharshi,
product.
sorry to interrupt you. We are running out of time, so kindly conclude the presentation.
Okay. Thank you, Gavi, for that. So then, like next one in the list is smart packaging. So intelligent packaging solutions are also there, like NFC and RFID that can be embedded in order to to monitor the temperature, humidity, and light exposure of the product during the process of transportation. And in case of smart logistic, here GPS can be used to locate vehicles location. RFID can be used to enable vehicles capacity along with like load volume, list of loading objects, and other things also. So this is about the green supply chain, and the next one here is how irrigation can be managed through IoT devices, green IoT devices, like through employing smart farming models like seed technology, irrigation systems, fertilization, precision agriculture, crop yields can be productivity can be increased. Like IoT and enhanced irrigation systems can be helpful in monitoring water usage, optimizing water schedules, monitoring soil moisture condition, weather conditions, determining leaks, potential leaks, and also drones along with IoT enabled devices can also detect diseases, spray pesticides on the particular plant which is being infected. Likewise, it is beneficial in many other things also. Like in the context of a mango tree farm, through IoT device, a farmer can properly monitor plant development, water availability in the leaves, effects of any disease or pest on the crop productivity, and can also ensure the time of harvest, thereby minimizing chemical usage, cost, and water consumption. Again, this is a suggested picture of a framework of a precision agriculture along taking in consideration of the IoT devices, enabled devices. So it becomes very important for all small scale businesses to monitor their carbon emissions. Like the increased use of internet, escalating computational demands have significantly contributed to the environmental emissions, like we can see here in this map. In this chart. Therefore, it becomes important for businesses to adopt green behavior through green IoT in order to mitigate carbon emissions and minimize power consumptions. So, through the scope of this green communication and network system, it is a subject to constant evolution due to the emergence of new technologies, standards, and practices. So technology's transformation is a multifaceted process that goes beyond simply enhancing specific functions within organizations. Instead, it entails fundamental alterations that have the potential to generate new possibilities for improvement. So this is all about my paper. These are the references I have taken from. Thank you, everyone.
So, what is meaning of ICT in your research?
Sir, here, ICT here stands for Information and Communication Technology.
Yeah, that is fun. But which kind of business cases you have considered?
Sir, I have considered here small scale businesses, like how they will be profited by using such devices.
And any particular use case you have considered for your research?
Sir, I have taken just a proposed case studies. I have taken like how like that smart dustbin. So I have taken some literature review from the foreign countries that there they have implemented, and
So,
I have tried to initiate it in our country also. How
good.
these small scale businesses
So
can
if the topic is
empower.
good, you can go also for patenting it. Fine. All the best.
Okay, so thank you very much for your feedback. Thank you, sir.
Thank you, Subhashri, for your presentation.
Thank you, Gargi. Thank you.
So the next paper is improving crop yield by preventing crop disease spread, recommending an automatic spray of fertilizer, and this will be presented by K. Deepa Thilak. You can share your screen and start the presentation.
Yes. Can you hear me? The screen is visible.
Yes, your screen is
Yeah,
visible.
okay, thank you. So, good evening, everyone present here. I'm Dr. K. Deepatila from Visakhapatnam, Bangalore. Here I'm here to give the presentation about the work what we have done to improve the crop yield by preventing the disease spread. And if the disease is done, then we have to find the suitable fertilizers and recommend it with automatic spray of the fertilizers. So in India, we all know that the major occupation is agriculture, in which farmers have very found difficult in identifying the crop disease, and if they identify later, the disease will not be spread and they will be in the loss. So we have decided to focus on this problem and give a proper product type solution using the IoT and machine learning, so that to give a complete product to the farmers. So we have completed up to 50% of the full product, which can to be improvised future more to get a full complete product. And based on this problem, we have focused on what are the work has been carried out in the existing one. That is, they used AI-based agriculture, where they used the app to where the image of the disease is given, and the image will identify the disease. From this disease, they will do this fertilizer can be given. So this support they have given to the farmer through the app itself. Okay, so all these works focused on giving only the recommendation by identify the disease. They also focused on multiple disease or single disease, and finally they give the recommendation this fertilizers can be allowed. Up to that stage, the current work, existing work has been carried out, and in some work they use the drones. That is a UAV vehicles which is used to spray the. I take the photo of the leaves and I feed this into the processor and give what disease is detected. So this is also costly. So these are the work till now is carried out, and from this existing methods, we have found that using the UAV vehicle is very costly, which is cannot be afforded by all the farmers in India. And prediction accuracy is good, but since you are using some deep learning and CNN methods, they are having some time consuming approaches also, and there is a possibility of having overfitting the data set also is there. And the apps recommends only the fertilizers, and the spray of the fertilizers is also done in the manual way. So which takes, even though we have found this type of disease is found prior, but it takes time to spray the fertilizer. It is also a waste of some loss will be incurred. So we have framed the problem statement that a complete system which is used to identify the disease in the leaves of any plant and to identify what fertilizer we can use, and finally automatic spray of that fertilizer. So that is the system is lagging currently. So our objective is framed to design an intelligent IoT system to identify multiple plant diseases, which with the help of a simple SVM classifier to identify the fertilizers and to automatically spray the fertilizers for the identified disease. So this is the overall architecture diagram of this intelligent plant disease monitoring system, where we give the leaf image. The first module will identify what type of disease, and then from the output given by this, we'll be focusing on recommendations for the recommendation system to the recommendation fertilizer spray system, where it automatically, with the help of the IoT water pumps, will spray the required fertilizer in the field in the automatic manner, no need for the manual support. So this is the overall block diagram of your IoT kit, where we have a simple Arduino code, and we have, this is the software side where we use the MATLAB processing and all the data sets with the leaf disease, with the infected disease and a healthy leaf also. And we identified specifically for this anthracnose disease, such type of disease is fed into the data set. And this pump motor 1, pump motor 2. So as of now, we have used only 2 motors, and so that we use 2 fertilizers for the simulation purpose, and we can add more motors if the full product is completely designed. So it's use case diagram. And the module says the first module is a leaf. There is a probability identification system where we use the SVM classifier, in which the leaf image is just fed into the process. The leaf image is given input, and this is pre-processed, and it is given for the feature extraction, where we extracted multiple features of the leaves with the example of variance, standard deviation, dissimilarity, homogeneity, and everything we covered. So which all these features, after extracted from the image, is fed into the SVM classifier, which classifies the leaf into diseased leaf. If it is diseased leaf, what type of disease? Since we classified into two or three diseases, and it is a healthy disease or what type of disease affected. That is the SVM classifier divided into different classes. And fertilizer recommendation system, based on the disease classified from the SVM, we identified that based on, it also gives a region of infected area. So based on the infected regions and what is the disease identified, the respective fertilizer is matched. So this will recommended system will find the which fertilizer to be sprayed to the crop because of the affected disease. So this is the overall IoT kit, where we are hardware. Once the auto fertilizer recommendation is done, this will give the signal to the pump motors. These 2 motors will spray through this nozzle, spray the fertilizers in the requested level. So this is, as of now, we are focused on spraying the fertilizers when the particular disease is done. And in future, we are focusing on to minimize the level of fertilizer also based on the region of affected disease. So this is the overall result, where even though we have CNN and deep learning methods are there, SVM classifies them with good accuracy and also with the less time with normal. Accuracy will be more and doesn't have any drawbacks like overfitting the data also, which is available in the deep learning models. So this is a user interface which is designed. It is a normal standalone application. It is not a web app, since it is to be used by the farmer in hand. We have to load the image and we have to give the contrast and stage income. After that, we have to segment the image. After segmenting, we'll be having the region of the disease affected area, which is region of interest, what we need. And we apply this into your, these regions will be extracted. These are the features. And with these features, we give input to the SVM. This classification itself will tell what type of disease is affected. Based on the disease affected, it will tell what is the, that motor will automatically start and spray the fertilizers. So there is no need for manual help to start the fertilizer to be thrown to the field. So this is our work. So we, since to help the farmers to have a good crop gain, we are focused on identifying the disease in the beginning stage itself and stop its spread by spraying the suitable fertilizer automatically with the help of this IoT model. And these are the references.
Hello.
Yes, sir.
Which data engineering techniques you have used?
So we used a SVM classifier, sir.
No, they are classifiers. My question is related to data preparation and data cleaning. Data
preparation, cleaning. Here we used we collected the data and we used this just filtering the data using I forgot that actually we used that's pandas, the library functions, and we have extracted them. So.
Which classifier you found better?
SVM.
Why?
SVM, because it is simple, you can apply to image also, and it is give a greater accuracy and it retain in a good way. It doesn't have any overfitting drawback also in SVMs.
How many features for data set?
We are, which is having more than 60, 70, sir. We extracted and fused only those what were listed in that screenshot. We applied in that.
So how you extracted? Have you used any dimensional reduction technique?
Yes, so that is image is converted into a dimensional action. We use a PCS.
PCA.
Yeah.
Fine. Good. Good.
Yes. Yes.
Thank you for your presentation.
Yes.
Let's move to the next. And the next paper is Panorama, a multi-language software information prospecting facility. And this will be presented by R.V. Krishna. I think he is not present. Let's move to the next paper. And the next one is Physical Activity Detection and Tracking Review. This will be presented by Harsh Vijay Srivastav. You can share your screen and start the presentation.
Okay, okay. Is my screen visible?
Yes, it's visible.
Okay. Okay, so I am Harsh Srivastav and my team and we have made a review paper regarding our final year project of it is a device on physical activity detection and tracking. So these are the contents which we'll be covering in this presentation. We have actually reviewed a total of 19 papers, but due to shortage of time, we have shortlisted the top 4 papers to be discussed in this presentation. So the first paper it is a comparative study by Hua Duang. So their model is developed using basically a random forest decision tree algorithm. They have classified different exercises like walking and climbing up or down. And and they have also used the accelerometer uh, from from the mobile itself, so that there is no any external use of any sensors. Now, for cleaning the data, they have used high pass filter, and then after segmenting, they are just giving out the values to the random forest algorithm for testing and training purposes. So the advantages is that there are in this paper they have proposed a system. They have made the system in such a way that the number of subjects were very high, which helped them to increase the accuracy of the model. But the disadvantage is, since they are using the random forest algorithm does not work the best in very high number of data sets while training. The second paper is a variable activity sensor system and its physical activity classification scheme. So in this paper, they have used they have made a wearable device, and they have made this using a KNN algorithm. Basically, they have divided the activities into 2 major classes: static and dynamic. Static is where something known as something sitting and standing, whereas dynamic is walking or running or even climbing. The advantage is of the paper is that they have reached a very high level of accuracy, but the sensor is placed on a very uh, on almost every part of the body, which might make the user very uncomfortable. Also, the data set they have used is very low in number, which might give a good accuracy, but will fall short during testing, according to our review. I'm sorry, my screen has frozen. Just I am sharing again. Yeah. So the third paper is by MN Shah Zainuddin. They have also used a mobile sensor, that is the accelerometer sensor, which is in our mobile, and they have also used a random forest decision tree classifier for classifying activities. But the major disadvantage again is that the framework such as personal dashboard to monitor the number of fitness activities conducted is not developed. So that is the major disadvantage of that paper. Now, the third paper is the artificial neural network based activities classification, gait phase estimation and prediction. So basically, gait phase is something known as a walking pattern of a particular individual. Every individual has different types of walking pattern, and this paper proposes a system which has trained which was trained on different types of walking patterns of different individuals. But the major disadvantage of this paper was that they have only tested it on 3 subjects and using only training from 5 subjects, which is very low. Although they have achieved 99.55% accuracy, but they have only tested it on 3 subjects. The advantage for this is that they have recognized different types of walking patterns and angles also, like whether it is ascent or descent. Now, we are in the process of making a real-time feedback and insights. So don't need athletes don't need the any walking or any running time parameters. Sometimes they need their specific sport activity parameters. So we are trying to make that in our system. It will ensure the athletes that they can move freely without wires or restrictions. And the sensors into sport and like the sensors which will be inside their sports apparel, it will not restrict the movement of the athletes in training and competitions. So this is the major comparison of the 4 major papers we have. The first one, we have seen that the number of subjects is 32 and the number of activities they have is 45. So which is very nice since they are using a very high number of subjects and very high number of activities. And they have acquired a very good accuracy with about 90 to 80%. Whereas in other papers, we don't see that, but the sampling frequency for one paper is 200 hertz, which is pretty nice. These are the references which we have used. These are the references which we have used in our in our review paper. Thank you.
Anyone having any questions? Okay. So let's move to the next paper. And the next paper is stock recommendations using machine learning and natural language processing. And this will be presented by Deepak Sinwar. You can share your screen and start the presentation.
Hello, am I audible?
Yes, you are audible.
Okay. Let me share my screen. It is visible screen?
Yes.
Okay. So very good evening to all of you present here. I am going to present my paper, that is stock recommendations using machine learning and NLP. So the paper ID is 338. This is the outline of the presentation. I will be starting with the introduction, then related work and few major contribution of the study, then with the methodology and results of the paper. So like as we know that recommendation systems are for stock trading are very like great significant, and for the layperson it is very recommended that we should recommend stocks from a like data. So the present study we presented is a threefold function, in which the first we presented a summary of existing recommendation systems, and then we applies and compare the result of like 4 ML models that are like popular. We found out in the first step, and then we applied sentiment analysis and compare the analysis of stock based on tweets. Okay, and the best of like two are like integrated in a portal, and we come up with a like front end to recommend that whether to buy or sell a share. So the first one, like we started with two kind of analysis. One is like fundamental analysis, and second is the technical analysis. So in fundamental analysis, like it is focusing on forecasting a company's future profit based on the data of its current and past profits, as well as the environmental and economical conditions. So this is like fundamental analysis we completed. Then the second is the technical analysis, which involves like recognizing trends in the financial markets based on the data available, as well as the other relevant information from statistics or other figures. So based on these recommendations, like we reviewed an existing recommendation systems and found that the for prediction of prices, like these 4 models are very popular. First one is like is LSTM, that is long short-term memory. It is like one of the state of the art model that is renowned to give significant more accurate results, because like it is remembering things for a longer period of time, and dedicated for like time series data. Then second is the Facebook's profit model. This is also a very popular model and applied on various stock recommendation systems, but like the performance is not good, and it is like not found suitable. And linear regression is also very popular. It is frequently employed in like conventional and non-defect stock recommendation systems. And in recent decades, like neural networks are like mostly superseded these linear regression models. And the fourth one is like ARIMA model, that is also popular, autoregressive integrated moving average. So based on many like literature study, so we identify these 4 models and believe that the time series data, they will perform better. So then we selected like some ML models and employed like sentiment analysis and this ML integrated work. Okay. So in this, like we perform this naive-based model, random forest, logistic regression, LSTM, KNN, and MLP based classifiers. So we analyze the performance of these models, and the best model is applied to like the front end part. So this is like an overall methodology. You can see, firstly, we obtain data from like Nifty 50 stock market data. And this is like a real data. And we applied the stock price prediction using these 3 models. One is ARIMA, FB Profit, and LSTM. And the result of this model is like integrated with the sentiment analysis. That is the second part. Here we obtained the data from the Twitter, and like what kind of environment, what kind of like news or kind of any other information is sharing for the stocks. So we obtained like sentiments from the tweets, and based on that, these LSTM, naive-bayes, random forest, logistic regression, KNN, and MLP models are applied to perform the NLP part. And finally, the results are integrated to that recommend that whether we should buy or sell a particular stock. So this is like divided into 2 parts. One is like stock price prediction, and second is like sentiment analysis. So for first one, we utilize this Nifty 50 stock market data from 2002 to 2021. And for sentiment analysis, stock sentiment analysis data is basically utilized. And this like data kind of pre-processing or data engineering, we can say, like we first tested the data in order to identify that which kind of like model is applicable on these kind of data. So we tested like 4 things: normality, multicollinearity, heteroscedasticity, and autocorrelation. And several tests was conducted on SPSS 26. So the variation inflation factor, that is basically utilized to detect the multicollinearity, and Goldfield-Quandus test for heteroscedasticity, and Durbin-Watson test for autocorrelation. Basically, we employed, and based on that, we tested the data and experimented with the performance of these 3 models: LSTM, ARIMA, FB Profit, on the first data set, that is containing the stock data for various companies. And we selected four major companies here for validation and simplicity. Like we identified four companies that are Maruti, TCS, Nestle, and Tata Steel. And the stock of these companies are highly traded in the stock market. That's why we selected these companies. And in the second phase, like a sample of like 5,790 stock related tweets with their corresponding sentiment value is used for the training and testing of the model. And like we can say that data is like not balanced, it is imbalanced data. So like 3,500 favorable tweets we identified, and 2,290 are basically negative tweets in all. So the data set is divided into a training set with the 4,632 tweets and testing with the 1,158, like 80-20 ratio, and after the pre-processing of the data. Now you can see the results, like we sample results are shown here. You can see that in the blue chart, blue line indicates the original trends of the data. And this red, or we can say orange line, indicates that it is the predicted share. So like these are the predictions by ARIMA model. So we tested these three models on like accuracies and as well as like RMSE values. So you can see that in this like four companies we selected, so the prediction is like almost same as of like original data. So like 2013 to 2020 we selected the year and tried to predict it, the both curves. One was the original one and second is the predicted one. And this is like done by the FB Prophet. So the picture is very clear. You can see that it is like not suitable for this kind of data, and we can't use the FB Prophet for stock recommendations systems. And on the other hand, like we have LSTM model, that is also very accurate model. And as for the like statistics is concerned, we can see that we have RMSE values. So you can see that the lowest RMS is given by this LSTM model. So this is like 9.7, and or we can say that 11.8, 10 point. So it is like around very less as compared to ARIMA FB Prophet, and FB is having more error. So you can see that this LSTM is like the best model for this kind of data. Now we considered like 6 models for sentiment analysis on Twitter data, and we found out that this naive-based model is like providing very good accuracy. And then further we selected this LSTM model and this naive-based model to integrate into a single like UI part. So this is like a web UI predictor. So here like the result of the both sections like price prediction and sentiment analysis are combined and using like Bootstrap developer. So we utilize this Bootstrap to generate this web-based UI. So you can see that startingly you have to enter some keyword for a particular stock, and then the list will be given to you, and then you can select any stock. And with the help of these models, like you can predict that whether it is suitable or not, and overall you can see that it is a positive, for example. So like you can it is recommended that you can buy a particular stock or not. So that was like a work. And in conclusion, like I can see that we presented the process of stock recommendations as a twofold process. Uh, pardon, sir?
Please continue. Sorry.
Okay, okay. So in the first one, like we presented twofold process. One is stock predictions and sentiment analysis. We apply various methodologies to check the basic characteristics of the data like normality, multicollinearity, heteroscedasticity, and autocorrelations. And for price predictions, we utilize 3 models, ARIMA, LSTM, and FB Prophet. And RMSE value is utilized as one of the key evaluation metrics for the same. And we identified that LSTM is better. And that is like applied on the front end. On the other hand, like for performance of naive base was found better than the others in case of sentiment analysis. So finally, we integrated both approaches for the ease of recommendation so that both can be combined. So you can say that it is like a hybrid model where ML and NLP part are basically combined together, so that for a like new user, we can like predict something that will be help hand for a user. So that is like overall work done by us. So any queries?
Any overhead for hybrid approach?
Look at the outset, like we did not identify any overhead for that, sir. like some data pre-processing part is like a very complex task, so it is taking a lot of time. But like when we identified some these kind of metrics, so like it is very easy to apply the models. Like otherwise, some authors are blindly applying the models that let us test this model on this data. So instead of doing that, like first if we try to identify these kind of testing, so little bit time is taking more, but the results will be better.
Why do you think that LSTM is doing better?
Because like for time series data, like it is remembering like concepts like, or we can say inputs for a long period of time. So that's why like it can remember things.
Fine. Thank you.
Welcome, sir. Thank you, sir.
Thank you, Deepak, for your presentation. So we are done with all the presentation. Now Ashwin can continue with his presentation.
Hello?
Yes.
Okay. Do I start from the beginning? Can I share my screen? Okay, it's visible, right?
Yes, it is.
Good afternoon to one and all present here in the conference. My name is Ashwin Shashi, and today I'm here to talk about our project Intelligent Traffic Control System using deep learning and computer vision. In our daily lives, traffic congestion is one of the many problems we face. To overcome this hurdle, we have come up with a solution. We created an analogy and worked further on it. The analogy being, let us take the situation of the policeman controlling the traffic, which is a sight we have all witnessed. According to Hello?
Yes, you're audible.
When I'm presenting, there's some issue with the presenting. Zoom isn't allowing me to present.
Your PPT is visible. Now it's not visible.
Okay, is it okay now?
Yes, it's visible.
In our daily lives, traffic congestion is one of the many problems we face. To overcome this hurdle, we have come up with a solution. We created an analogy and worked further on it. The analogy being, let us take the situation of a policeman controlling the traffic, which is a sight we have all witnessed. According to the traffic present in the junction, the policeman controls the vehicles present in the road. This is considered to be very effective, but isn't very practical as the policeman cannot stand in the junction for a very long time due to the adverse weather conditions. And so to implement the system, we have taken the inspiration from the brain of the policeman to take intelligent decision and the eyes of the policeman that inspect the traffic conditions of the road. The deep learning model can replace the brain and the computer vision can replace the eyes of the policeman. The purpose of our project is to reduce congestion, improve travel times, enhance road capacity utilization, minimize fuel consumption, and decrease pollution in urban areas. Using a project, we can analyze real-time data and adjust signal timings accordingly, thus helping in creating an effective traffic flow. This model that we use here is a YOLO model, the state-of-the-art real-time object detection. Now, the problem we aim to address is the significant traffic congestion in urban areas, which leads to delays, decreased productivity, increased fuel consumption, and heightened pollution levels. The traditional traffic control system are not able to adapt to changing traffic conditions. Here in the PPT, we have addressed few papers and few research done by the TomTom Traffic Index 2020, ranked several Indian cities among the most congested in the world, including Mumbai, Bengaluru, and Delhi. Another study from the Boston Consulting Group estimated that traffic congestion cost the economy by Mumbai around 1.5 lakh crore, which is $21 billion annually. According to the Center for Science and Environment, traffic congestion in India cities results in an estimated fuel loss of over 1.4 lakh crore rupees per year. In total, 6 SDGs are applicable in our project. They are SDG 3, Good Health and Well-being, SDG 9, Industry, Innovation and Infrastructure, SDG 11, Sustainable Cities and Communities, SDG 13, Climate Action, SDG 16, Peace, Justice and Strong Institutions, and SDG 7, Affordable and Clean Energy. But we focus on SDGs 9 and 11. SDG 9, Industry, Innovation, Infrastructure. The system requires technological innovation and infrastructure development, contributing to efficient and sustainable transportation systems. And SDG 11, Sustainable Cities and Communities. Intelligent traffic control systems create sustainable and livable cities by reducing congestion, improving air quality, and enhancing transportation efficiency and accessibility. Here are the few research papers we have focused on. A computer vision-based approach for automated traffic management as a smart city solution. It's a 2020 year paper. Smart traffic management system using deep learning for smart city application, 2019 paper. And intelligent transport system, 2010 paper. The methodology of our project is that we are utilizing deep learning algorithm, the YOLO model, for accurate real-time detection of vehicles from camera, the computer vision. The model analyzes each frame, identifying vehicles based on their bounding boxes, and they are classified accordingly. Our model detects emergency vehicles and differentiates them from other vehicles to prioritize them, like ambulances, fire engine machines, fire engine vehicles, etc. Valuable information from detected vehicles are extracted using the YOLO model. This information is used to analyze the traffic patterns to gain insights into current traffic conditions. The vehicle count and traffic data is utilized to dynamically adjust the timing and coordination of traffic signals. The system continuously monitors the traffic condition and allocating signal timings based on the detected emergency vehicles, vehicle count, and traffic density in real time. The obtained information is utilized by Python code for dynamically determining and changing traffic light signals to green or red based on real-time traffic conditions. Here is a flowchart of a methodology. There are the computer vision extracts information from 4 different lanes. It captures the video and it undergoes video pre-processing. The YOLO object detection it takes the input of the video, pre-processed video, and it counts the density of each lane, the vehicle density, and it also detects the emergency vehicles. It is the output of this is then given into the Python code, and the priority is set, and the timer is also set. This is a Python code logic where it takes data from both lanes. It checks for emergency vehicle. If there is emergency vehicle, the lane which has the emergency vehicle is made green. If there is no emergency vehicle, it checks the difference between the lanes and checks if there are significant difference. If there is a significant difference, the lane with less traffic density is made green. Otherwise, they check the difference and see which has more traffic density. If there is no significant difference, the lane which has more traffic is made green. Here's the proposed model that we did. It includes Arduinos, LEDs, limiting resistors, breadboard, and jumper wires. Here's our hardware. This is a simulation of our hardware. This is a video we have taken of the Mumbai highway. This is the pre-processed video. It is given into the YOLO model, and this is the result of the YOLO model. It detects the vehicle and gives the vehicle count. There's a second video where emergency vehicle is there in the lane. And here is the result of the YOLO model detecting the emergency vehicle. There's a green and a red annotation for emergency vehicles. Here is the result. The result comes out as a text file. F is for false. There is no emergency vehicle in the first video. And T is for true. There is emergency vehicles present. And the number here, 20 and 26, are the vehicle count or the vehicle density in that particular lane. To summarize what we have done so far, is creating a robust traffic control system that dynamically adjusts traffic light schedules for seamless flow of traffic. Besides this, our team has added a feature that differentiates us from the rest of the intelligent traffic control systems. Our model has been trained to detect emergency vehicles and prioritize those lanes that contain the emergency vehicle and optimize the system in such a way that the emergency vehicle is given top priority and that the lane is let free immediately. Through this project, we are able to complete the aims put forth by our problem statement. Here are a few references. Thank you. Are there any questions?
Yeah, good work. You have captured the data, or it was available with some Mumbai authority?
It was taken, we have downloaded the video from the internet.
Good work, good work. All the
And then
best.
we have sent it to our model. Thank
Yeah.
you.
Madam, how many are left?
I think everyone is done.
Done. That's good. Good. Fine.
Okay, so we have come to the end. I sincerely thank our authors for their excellent presentations and contribution in this session, and all the participants for being a part of this international conference. I hope this session was informative enough. We, on the behalf of the whole team, thank you for the support during this 8th version and the previous 7th versions of the conference. We will be happy to have you in the 9th version in 2024. All the presenters will be getting their digital certificates through email within 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of ICTCS 2023. I also thank our session chair, Dr. Parikshit Narendra Mahalle, for chairing the session. A token of appreciation to the chair on the behalf of the team ICTCS 2023 and Global Knowledge Research Foundation and partners. Sir, would you like to provide your reviews for this conference?
Thank you. Thank you, Gargi madam. All presentations are very good. And hope you all have observed that most of the presentations were based on AI. So it shows that how AI is driving us. And many of the presentations were really for the benefit of society. So congratulations to all the authors and thank you to ICTCS 2023. Over to
Thank
you.
you so much, sir. Thank you for your valuable presence. So now I request all the participants to please turn on the camera so that we can take a quick snapshot.
Thank you all. Thank you.
Thank you, everyone.
Can I leave, Gargi madam?
Yes. Thank you, everyone.